Okay, I thought it would be a good time for us to review all of the things that have happened in Chapter 10 because it's been a lot. We've been doing a lot with Chapter 10. So I'm going to do a summary map of what's going on in Chapter 10 so far. I'd recommend that you follow along so that you have something like this in your own notes. But whether you follow along or not, I want you to stop and think back on what's been going on in Chapter 10. So I have my paper sideways, and I'm going to do a tree map, and for now, my tree will have 4 branches. Okay, so Chapter 10 is all about functions. And then I'm going to have 4 branches coming off of that. Back up a little bit so you can see. Alright, so my first branch is about the new functions that you learned in Chapter 10. So you learned 2 new functions in Chapter 10. New to you functions. The first new function that you learned in Chapter 10 was the square root function.
Easy.
And we learned that the graph of the square root function, if you're going to graph it, actually has a starting point because you can't use negative numbers in the square root function. So the graph of the square root function always starts at 0, 0, the origin, and then the square root function is always increasing up to infinity, but slowly up to infinity. We learned that the square root function has a domain. Remember, domain is from left to right. A domain that includes 0, so it has a square bracket on the 0, and goes up to infinity because you can plug in really giant numbers into the square root function. We found out that the range of the square root function also starts at 0 and goes up to infinity. So that was the first new function that you did. The second new function that you studied was the cube root function, and the cube root function, when you write it in notation, looks the same as the square root function except for a little 3 as an index value. And the cube root is if you multiply 3 numbers together to get that x value. What is that number? And so if I graph the cube root function, you learned that the cube root does pass through 0, 0, so that's an important point on the graph. 0, 0 is called an inflection point for that graph. You don't need to know that, but that's what it's called. The cube root function increases up to infinity, and then it also goes down to negative infinity in that direction. It has that curved lightning shape that we talked about. The domain, because you can have negative numbers in the cube root function, the domain is all real numbers, and the range is also all real numbers. For both of these new functions, you were working with the average rate of change. You practiced that skill. We first introduced average rate of change last chapter, but we continued it this chapter. The average rate of change, or actually maybe it was chapter 8 that had average rate of change. Anyway, the average rate of change is always going to be on some interval of x, so from some number to another number. Oops, that should be a b. And the way you find the average rate of change is you plug both numbers into the function and subtract. That gives you your rise, and then your run is going to be subtract the x coordinates. So remember, these are y coordinates on your function. You subtract your y's and you subtract your x's to get the average rate of change. So working with that formula was important in sections 1 and 2. Okay. Then we spent some time looking at graph properties, so properties of graphs. The big ones, the ones that were new, that we really emphasized, we emphasized this new domain and range notation. So we've got domain and range. We really worked with domain and range here. Domain, when we start doing that notation, we go from left to right. We use a bracket if it's included.
Look at all those stuff I've got at the museum. Look, 1, 2, 3, 4, 5, 6, 7, 8.
And we use a parentheses if the point is not included. The range and domain is x coordinates. So you always read the x coordinates off your graph. Range, in order to find those points, we go from bottom to top of our graph. And again, we use the same notation. The bracket includes the point, the parentheses does not. And for range, it's going to be y coordinates. In this section, the other big new idea was end behavior.
End behavior?
Yep. End behavior is we look at both the right end of the graph and the left, but that's all, because your graph only has two ends, a left and a right. And for the right end behavior, the notation is as x goes to infinity, that part never changes, then f of x goes to something. It might be a number, it might be an infinity, it might be a negative infinity, depending on whether, so if f of x is pointing up to the sky, on that end, then we would say infinity. If f of x is pointing down to the ground, we would say negative infinity. And if f of x is leveling off at a number, then we could put a number in that spot. The left end behavior of your graph would be as x goes to negative infinity, and then we say something about our function. Could go to infinity, could go to a number, could go to negative infinity. Okay. The next thing we did in chapter 10 was we did translations. We did horizontal translations. So we said, well, a horizontal translation would be if you add a number to the x portion of your equation. So your new function based on a parent function would be f of x plus or minus h. And for a horizontal translation, we always use the opposite sign. So if it's minus a number, that means your graph is going to the right, even though that seems like it should be left. And if it's plus a number, that means your graph is going to the left, even though that seems like it should be right. Then we also did vertical translations. A vertical translation is added on to the end, so your function would look like f of x plus or minus some number. And that one we don't use opposite sign. That would be the sign that you would expect. So plus would be up and minus would be down. And those ones are going to be at the end of your function, not attached to the x. Finally, the last thing we did was stretches and compressions. And there were two kinds of stretches and compressions as well. There's a vertical stretch or compression, and a vertical stretch or compression would look like a number outside times your function. And if your k is bigger than 1, that's going to be a stretch away from the x-axis. And if your k is less than 1, that's going to be a compression towards the x-axis. Then the second type of stretch or compression we did was horizontal. A horizontal stretch is going to be attached to x in the same way that a horizontal translation is attached to x. So it would look like f of k times x. And that one, again, horizontal is horrible. Those are kind of opposite. So if k is greater than 1, that's going to be a compression towards the y-axis. And if k is less than 1, that's going to be a stretch away from y-axis. Okay, that's a summary of all of what we've done in Chapter 10 so far. You should spend some time with this review, because we're getting close to the end of Chapter 10. We're not there yet, but there will be an assessment on Chapter 10, so you have to be comfortable with the ideas we've studied so far. Also, a reminder to ask questions if you need to, and I miss you all.